Hello, everybody. Welcome to another episode of Precision Perspectives. I'm your host, Jordan Yates, marketing engineer at Knowles Precision Devices. Today, we are hosting Brandon Peeler, the North America Automotive Key Account Manager at Knowles Precision Devices. Brandon, say hello to everyone.
Hi, everybody. Thanks for having me, Jordan.
Of course, your title is a mouthful. I barely got it all out.
Sure is. Sure is.
Brandon, I'm excited because you have a really cool role being involved in the electric vehicle market, especially today's day and age with how booming it is. So, today we're going to go through and talk about the world of electric vehicle infrastructure, and hopefully, you can shed some light on the roles capacitors play within that infrastructure.
Sure.
Great. Well, we're going to get first started on our segment that I like to call Say It Plainly. Now, as somebody, even though I have a technical background, I always find it helpful for those who are still getting their feet under them to just have what we say, like a plain English definition of what we're talking about. So, for our listeners who may be new to the electric vehicle infrastructure discussion, could you explain in simple terms what it encompasses and why the term infrastructure in like charging is important in this conversation?
Sure. So I think it's important to understand, kind of getting into the basics. There's three levels of EV charging, right?
Hmm.
So level one is your home charger that operates off your regular plugs at home, 120 volts. So that's going to be good for like your plug-in hybrid vehicles. Charges pretty slowly though, 3 to 5 miles per hour is usually what you get.
Wow.
And then you go up from there to level two chargers. So again, these are a lot of times for home use, but these would operate off of 240 volts, and these can charge at like 12 to 80 miles per hour, right? So much faster. These would be suited for your actual, full battery electric vehicles. And then you get into the big ones, the level three chargers. These would not be at home. These are, very expensive, tens of thousands of dollars. But these are going to be operating off of DC current, and these can
Hmm.
charge up to 15 times faster than your level two chargers, right? So these are the ones that you hear about that can sometimes charge in 30 to 40 minutes from empty, right? Or 10 minutes up to 80%, things like that. So, these are really kind of the bread and butter type of chargers that Knowles is going after with our products, because this fits very well because these are high voltage, usually 480 volts and higher. Then there's kind of an additional type of charger that you don't hear a whole lot of, but those are going to be wireless chargers, so vehicle wireless chargers, and
Hmm.
those are kind of still in development. They're really not very widespread yet, but hopefully those will be coming out in the future. So you'll be able to just back your car into your garage and have a charging pad underneath, and it can just wirelessly charge the vehicle without plugging it in.
Absolutely, yeah. And the funny thing is, being in this industry for a couple years now, this stuff seems so intuitive to me. But I remember a year and a half ago being like, what is the difference? Level one, level two, level three? Like, I thought that that was so overwhelming and like confusing, but I think you
Right,
did a
right.
great job breaking it down. And it's exciting to see that there are new developments like the wireless charging that are happening. And I wonder what comes next. Like, where do we go from here? Can it get even faster? Who knows? But I'm curious if you could explain to us how capacitors fit into this. Now, if you guys, you'll go back and listen to episode one if you aren't familiar with what a capacitor is, but they play such a crucial role in these, chargers, whether it's level one through three wireless. Can you explain to us how they fit into the system?
Sure. So today we'll kind of focus more on like level two, level three mostly, and a
Okay.
little bit of the wireless. But capacitors of different types can be used in circuits to accomplish different things, such as filtering. So whether that's to filter unwanted noise or EMI, or to remove any AC from a DC line.
Yeah.
You also have snubber capacitors that reduce inductance, or resonant caps to output a specific frequency. So kind of many different things, and really Knowles supplies all of those from a ceramic capacitor standpoint. And then outside of ceramics, there's film caps and tantalums and different technologies like that. But what Knowles does is all ceramic based.
Awesome. Yeah, it's kind of crazy because I remember hearing electrical noise for the first time and being like, what?
Right.
Noise, electrical, like zapping is like, what is it? And so I don't think people fully understand like the safety concern of if there is this noise, like what could happen, like electrical fires, like transmission issues. Like, can you kind of give us a overview of like who should care about this noise? Is it people designing it? Is it your everyday person driving it? Like, who does this noise that we're suppressing affect?
Well, so that would be definitely for the designers, the engineers, right? They're the guys who are going to care about that unwanted noise. For the consumer, I think it's really more about the speed, right? And so that's really been, kind of driving a lot of it, right? The with the adoption of electric vehicles, there's been a just dramatic increase in battery electric vehicles and hybrids, right? And you hear it in the news all the time that all these automakers are trying to produce more and more. So the race is really on to add more chargers, right? Today, there's something like I think 160,000 chargers across the U.S. And we're expecting to be able to add around 500,000 more chargers by 2030. So and that's just in North America, right, or in the U.S. So globally, it's huge. This market's just going to be booming. And yeah, I'd say from a regular person, all you really care about is how quickly you can get your car charged, right, and the availability of chargers. That's really going to weigh heavily on whether you want to purchase an electric vehicle or not.
Yeah, it's actually kind of interesting that as the capacitor manufacturer, just one small, tiny itsy bitsy piece of this big puzzle plays such an important role in the development of these chargers getting faster, getting more of them out. Because, we have to produce on the component level before manufacturers like Tesla can make more. And I'm not saying us to Tesla specifically, but just an example of somebody who makes electric vehicles. Could you kind of elaborate on how capacitors contribute to this mission of creating our electric vehicle world? Like, I mean, I kind of said it sort of plainly how they fit into the supply chain, but like, what happens when there isn't capacitors? Like, what do we do? Like, why are they so important?
Well, I would say for the perspective of the infrastructure and these boards, ceramic capacitors are going to be really important because we're able to help designers downsize a lot of these boards. So with power levels going up to be able to charge faster,
Hmm.
that's going to cause an increase to the size of components, right? Like especially with film capacitors that take up a relatively large amount of space. So by using ceramic caps, we can help these engineers and designers to downsize while also increasing performance. And
Hmm.
then once you have reduced board space, you can also sometimes see a potential overall cost savings of the entire system, right? And a reduced footprint, which helps if you're trying to get 500,000 of these things, spread out across the country, right? So they always want to make it as small as possible, as cheap as possible, and as high reliability as possible. And that's really where I think ceramics can come in and help that.
Yeah, I mean, that totally makes sense because if we are getting better on the very board level, then I imagine that the system as a whole gets better too. And so
Right.
pressure's on, we got to perform.
Yeah, yeah, exactly.
So, can you kind of give us a real world example from board to charger, like what it looks like implementing a capacitor into the electric vehicle charging structure? So, imagine you start with the capacitor at the shop, just sort of like who it goes to, design process, how it gets out there, and then finally someone plugs it into their car. What does that look like?
Well, your typical charging station itself, right? It's going to be made up of multiple power modules. And
Hmm.
then these things get stacked together to increase or decrease the power and charging time. That's
Okay.
kind of the basic overview. Passive components like capacitors, they're going to be used within these different power modules for things like filtering, snubbering, resonant tank applications, and for providing safety protection for line to line or line to ground circuits, right?
Hmm.
So basically, we would work with the engineers at these different companies and help them to spec in capacitors that would, work well for what they're trying to do, right? And also try to spec it to again have the smallest footprint, give it the best performance, all those kinds of things. And yeah, then they design it into the system, and then eventually it gets out, gets manufactured, and gets to the end consumer.
That's cool. How often would you say you're going and working with vehicle manufacturers versus somebody that is building a part of the power module that goes into these charging infrastructures later on? Is it a good mix, or do you see a lot of vehicle manufacturers doing it in-house? Like, what are you seeing a lot of these days?
Well, I'd say it's a good mix. So it's sort of the Wild West, I would say, right? There's a lot of new startup companies that are trying to get into this because they see the opportunity, right? We need hundreds of thousands, probably a million chargers need to be added over the next, say, 10 to 15 years, right?
Hmm.
To really satisfy demand. So it's a huge potential market. So you've got some of the OEMs, especially a lot of the EV OEMs like Tesla, of course, Rivian. They're doing a lot of this stuff in house. Even some of your traditional OEMs like Ford, they're also doing a lot of it in house. Then you have a lot of startup companies or kind of new players that are just doing charging stations, like ChargePoint would be probably the biggest one here in the U.S. So you see, I would say you see a good mix of both, and we're trying to work with all of them.
Absolutely. And I want to get a little deeper into sort of the technology where we talk about we want faster charging stations. Great. We make the level 3, the super fast ones, but you can't plug that into just any electric vehicle. Can you kind of explain like the trickle down effect of if you want a vehicle that charges faster, that it needs to have certain capabilities to connect to these fast chargers? It's not a one size fits all.
Yeah, so on that front, I think that the faster charging is going to be the higher voltage applications.
Hmm.
So a lot of your stuff that's out today is going to be your 400-volt system on the battery
Okay.
side. And so that's going to kind of limit how quickly they can charge. And then if it's 800 volts, that's kind of the next round of what we'll see for a lot of the new trucks that are coming out, the heavier
Hmm.
vehicles or higher performance vehicles. And so with 800 volts, they can charge a lot faster. And so that's where you can see a lot of these times getting reduced. And so when we talk about charging stations, a few years ago, we were talking about 480-volt systems. Now we're getting to 1,000 volts. We're even talking to customers about some new developments that'll come out for like commercial vehicles, for real heavy commercial vehicles, and they could be up to 2,000 volts, right? And so as you increase that voltage and current, that's going to give us much faster charging times.
With all these new things that are happening, and the way that our company is structured, Knowles Precision Devices, how often is it that you get a request from a customer saying, we want to achieve this, and this is our end goal? And then you have to go back to the engineering team being like, does a capacitor exist for this? And they're like, no, but we'll make one. We'll do some R&D. Like, what happens in those kind of situations? Do you have those?
Yeah, for sure. So that's pretty common, right? So a lot of times these engineers will reach out to us, and they've got their part of the circuit they're working on, or their certain application, and yeah, they're basically trying to find out, what's the latest and greatest from Knowles? Can you help us? Or maybe today they're using a different technology, like maybe a film capacitor, and maybe they want to reduce the footprint size, and so that's something where we look at it and say, okay, yeah, maybe we can replace this, one large footprint film cap with one or two smaller ceramic capacitors, right? And so we can reduce that footprint. And then typically, if it's from film to ceramic, you usually have a little bit better performance, lower ESR, lower ESL with ceramic. So things like that. But yeah, it's quite often where, we'll get engineering involved. That way we can have our apps engineers talk with their engineers and kind of come together and see if we can help. And that's the cool thing with Knowles is we are always open to making custom parts if we need to, adding, different suffix codes to parts for specific applications if we need to.
So how often are you kind of surprised that like the engineers at Knowles make something work that you thought maybe sounded kind of outlandish, where you're like, I don't know, but I'll ask, and then they make it happen? How often does that happen? Or do you just have a lot of faith in the engineers and they think they could do anything?
So when I first started with Knowles like 6 years ago, that was when we started seeing a lot of interest for like the vehicle wireless charging. And
Hmm.
so with the wireless charging, it requires, a huge amount of power in this kind of charging pad. And so we were seeing applications where we might have 1,000 or more ceramic chip caps in
Wow.
like series parallel arrays, right? And so there was problems trying to get the heat to dissipate correctly and things like that. And so over those years now, our engineers actually ended up coming up with kind of a cool solution where we
Hmm.
have this large capacitor assembly now. And so these things are kind of configurable, for the end customer, however they want to have it. It can be different sizes, it can be stacked taller and shorter, but basically it can give them the power density that they need without having to, put 1,000 or 1,200 individual components and place them on the board. So our engineers are always they always amaze me, right, with what they come back with and the cool stuff we can come up with for these kind of applications.
That's a really good example. I love that. I think when I was first getting introduced to the electronics world, I was like, this is all magic. Like I don't know how
Yeah,
it happened, so I didn't ever know what was realistic to ask for. And I assume as you get experience in the industry, you start to build a filter for that. And you do it, but you also want to be cautious of not filtering too much because like you said, we can be surprised by our engineers' capabilities. They just know so much more than us. It's so cool to have them on the team to bounce ideas off of.
yeah, for sure.
Now, I want to get into our next segment, which is going to be a rapid fire round. These are going to be a bit more fun and quick questions. So, I want you to share, if you can, either a fun fact or a unexpected anecdote related to capacitors in the EV infrastructure. Now, it could be a funny question that maybe someone in your family's asked you or anything, because sometimes, people ask silly questions when they don't have familiarity with the industry at all. So,
Oh,
any
sure.
story you could share to lighten the mood. I love a good funny story.
I would say the number one question when people ask, oh, what do you do? And I work for a capacitor company, right? And most people when they think of a capacitor, they're like, a flux capacitor,
Oh,
so actually I keep this here at my desk, right? So we've got the original flux capacitor mobile right here.
oh my gosh. That's funny. That happens to me too.
Yeah, but that's how I explain it to my kids. I'm like, yeah, dad works for the company that makes the flux capacitor, but
It's so funny because like that's what my dad loved that movie as well. So that was his only association. And most of the time people don't know what a capacitor is at all. So I think this
yeah,
podcast could be kind of a fun way to introduce everybody that isn't as familiar to the world of capacitors because we have a lot of
sure,
kids in college that are graduating and trying to figure out what industry to go in. And when you look at capacitors alone, it's not the most flashy industry, but then when you take time to learn the applications they're a part of, that's when it becomes really cool. And I think electric vehicles is proof of that.
yeah, definitely.
Yeah, well, Brandon, this has been fun. I'm curious, do you have any more sort of insights or notes you want to leave us with about electric vehicles, capacitors in general, or just anything that you want to share with the audience before we sign off?
I would summarize for electric vehicle infrastructure for Knowles. I would say there's three words, right, that really categorize our capacitors, and that would
Hmm.
be small size, high performance, and high reliability. So those are kind of the main three areas that we play. I think where we can really help with this infrastructure and get these 500,000 new units in production, right?
Yeah, and I definitely agree. Those are some good key points. And if somebody wants to reach out to you because they thought you said something enlightening and they want to get to know your experience a little more, can they reach out to you directly? Is that something you're open to?
Yeah, yeah, absolutely.
All right. Well, we will put his email in the description of the episode. That way you guys don't have to like write it down. But yeah, that's pretty much all we have today. And I want to invite you guys, if you have any questions for Brandon or that you want us to ask a guest on the show, we can always bring Brandon back and do another episode. So just write into us. And yeah, we're excited to see you all in the next episode. Thanks so much for listening. And Brandon, thanks for coming on.
Awesome. Thank you, Jordan.
See you guys later. All right.